Hello friends, myself Aniket Nikam. Today we are going to learn the states of transactions. Okay, so yesterday we have seen what is transaction, what is concurrent execution as well as serial execution of transaction, and today we are going to learn what is schedule also and what are the problems with the transactions, why we need to have some protocols. Okay, now in this diagram you can see that transaction have those states. So you can see that 5 states are there, and first state is what? Active state. When transaction starts executing its operations, it is in active state because it is running in the system on CPU. And after transaction completes some of the instructions, then it is in partial committed state, because not all the operations of transactions are executed, but some of the transactions are executed, and that is called as partially committed state. And after that it completes all the operations, then it goes to the committed states, and then we can see that transaction is successfully completed. Okay, and due to some reasons, what can happen that due to abort, or you can say due to the different scenarios, we can all the partially committed transaction, they will go to the failed state because they are unable to execute all the operations, and that is called as failed state of transaction. Okay, and next is you can say aborted state. When failed operations of a transaction due to some reason they cannot run again in system, and they go into the aborted state, and this can happen due to the kill operation, restart operation, and software and hardware failure. Okay, so please look at the diagram. This is very important to understand this state transition diagram for transactions. Okay, now we are going to see what is concurrent execution of transaction and what is serial execution. Now we will see what is concurrent execution of transaction or parallel execution. Now in this on board you can read that what is concurrent execution: interleaving operations of a transactions, that is called as concurrent execution. So now question arises in our mind, what is the need of concurrent execution? So basically concurrent execution will look like this. Okay, so at the same time transaction T1 and T2, they are performing operations. Let's say this is read A, then read again A. Okay, then A is equal to A plus 10, like this, and it is going to have some operation A is equal to A plus 50, like this. So this is what completing in sequence, in parallel. Okay, now one serial schedule is like this, where first transaction T1 is going to complete, and then transaction T2, and this serial transaction always give us the consistent state. Okay, but in concurrent execution there is problem. But before that we will see that what is the need of concurrent execution, what is the need of parallel execution. The answer is very simple. The first is understand read and write operations. Those are called input output activities, which are directly deal with the disk. In database, whatever data we are going to store, we are going to write on the disk and read from the disk. And another activity is A is equal to A plus 10. This activity is what? CPU activity, arithmetic operation, where we are going to work on the variables. Okay, and those two activities can run parallelly. Okay, and they will not have any problem. When we execute in serial manner, what happens that the CPU resources, especially disk and CPU, are not utilized properly. The utilization is not, you can say, optimal. That's why we are having the parallel execution or concurrent execution. The first reason is to avoid longer waiting times. Let's say we have 10 transactions in one schedule, T1, T2 up to T10, and then let's understand serial schedule. If one transaction is going to complete first, then second, third, now T10 is going to starve. It is having a problem, it has to wait for long time. Okay, and then that is a problem. To solve this problem, we can run all the 10 transactions parallelly, concurrently, so that no transaction will have longer waiting time. Another thing is input activities and CPU activities, as I told, those can run parallelly, and that leads to enhanced utilization of CPU as well as the disk. So that is the reason we go for concurrent execution. Now there are some problems with concurrent execution that we are going to see those problems. Now we will see what is schedule. Okay, now in schedule there are different transactions. Schedule represents the order in which the operations of a transactions are executed. Okay, so that is order, and we represent schedule in this way. Now in question paper there are different types of representing schedules while writing or with help of table. So this is what say transaction 1, 2 and 3, and those transactions will have the instructions in different order like this. Okay, and this will be the, you can understand, this will be the different order in which the transaction will be execution will happen. Okay, that is what schedule. Now there are as I told there are different problems with the serial schedule, concurrent schedule, parallel schedule, and we are going to see those problems. Now we saw the problem. Now the problems due to the concurrent executions is last update problem. What is last update problem? I told in my last video with example, that is what same as last update problem. Understand, we have two transactions T1 and T2 and they are executing in different order. Let's say they are concurrent. So first is read A, and value of A we are having, let's say 10. Then this performing operation A is equal to A plus 5, and then meanwhile what happens, this is again reading operations, same read A. Then we will be having here write A, and this will be having operations A is equal to A plus 100 like this. So now if you observe here what is happening, this read operation is reading the value of 10, whereas this read operation is reading the value 10. But if I write this read operation after the write operation, then what will happen? Let's say here I am having a write operation, write A, and then this read is having A operation. So this value will be how much? This value is reading is not 10 but 15. Okay. Now in this video, like you can understand here, last update problem is what? We are losing the original value. We are not having consistent value. One transaction, if we execute concurrently, we are getting suppose 350, but originally if we execute it serially, concurrently it is 300, but if we execute it parallelly or concurrently serially, then it will be having 350. So there is a difference between concurrent execution as well as serial execution, because we are overwriting the value of A. Now another problem is dirty read problem. What is dirty read problem? Reading uncommitted data. This is called dirty read problem. Now in this case, if I want to show you dirty read problem, now it's very easy to understand. Okay, so now this transaction, this schedule having two transactions T1 and T2. Now let's say read A, and then I am having A is equal to A plus 10, and I am writing A, and then I am reading this A value. Problem here is this value is not committed, and we are going to read this value, and it is, we will give the correct result, but still value is not committed. So it will give problem with different multiple transactions. So that is called as dirty read problem. And a last update problem, once I wish to discuss this. So what is last update problem? Let's say the transaction T1 and T2 schedule S2, and I'm having this read A is equal to A plus 10. Again I am having value of read A, then I'm having A is equal to A plus 100, and then I'm going to write A, and I'm going to write here A. So now understand, originally if we execute those parallelly, serially, then what will happen? A is equal to value of A is, let's say 50 here, so we will get here 60, then we will write 60, then this will start execution. If we go in serially, then it will read 60, then add 100, 160, and this will write final value is 160. Now the actual value should be 160 of this transaction, consistent value, but if we execute in this concurrent manner or parallel manner, what will be the value here? A plus a is equal to a plus 10, that is 60, and we are going to read here this value. Which value will be read? So value is what? 50. So we are going to read here 50, and then we will add here 50, we will have 150, and this is going to write this value is 60, and then this is going to write finally the value overwritten, value will be overwritten. This is conflict operation, and we will have the value of 150, and we are going to write this value as 150. So the difference between 160 and 150, because originally it should be 160, but it is giving 150. So this is what? Inconsistent state, and this is called as lost update problem. Now third is in unrepeatable read problem. Now if you read the definition, just look at the definition. When a transaction tries to read the value of a data item twice and another transaction updates the same data item in between the two read operations of first transaction, as a result first transaction is reading valid values of the same data item, where other transaction, the second operation, read operation, is not going to read the correct operation. Okay, how to understand this problem? So very simple, and this is called as unrepeatable read problem. Okay, so this is one transaction, let's say read A, and I'm going to having again, let's say read B and then read A. Now A is equal to A plus 50, like this, and again it is going to have let's say write operation, A is equal to A minus 10, then write A. Okay, so here again it is reading value of read E, and in between let's say this is writing write A. Okay, so now in this transaction, in this schedule T1 and T2, you can see that we are reading, transaction T1 is reading the value twice. Okay, and in between there is a write operation. Okay, so this is called as unrepeatable read problem. Okay, now in this case, this transaction is reading correct value of original table, let's say that is 100, A is equal to 100, but this is not reading, this is reading 150, and this is called as unrepeatable read problem. Hope you understand this problem. We have two read operations for the same transaction, and in between the value of that same data item is updated or it is written. Okay, so those are the three problems, and now we are going to see the different schedules. What is a complete schedule, what is a strict schedule, what is like you can say serializability, serializable schedule. Okay, so now different concepts are very important, and based on this we are going to solve the problems asked in GATE, NET and NIC. Okay, so thank you very much for watching this video. If you like the video, please subscribe the channel and don't forget to press the notification button. So thank you very much.